Hello everyone, how are you doing guys? I'm here with my friend Max and today we have a great guest to talk about many things very fantastic. Alright Max?
Oh yeah, it's amazing. It's amazing to having our guest today. So he's the one that I how can I say I'm in debt with him because when I goes to when I goes to GeekCon
Oh,
in last
Krakow.
year, I talked to him and but everything doesn't work. But today it's working. Thanks, Gabriel, to reach out him and let's bring him to the stage. What do you think?
Okay, let's go. And today we have a
What?
great Rustam.
Hello. Good to be here. It's really great to be here. It's great to thank you for having me, guys. It's really nice to join you today.
Alright, and
Yeah,
guys, I have only one thing to say. Write to us where you watch us because we have an international person. It's from Oslo, Norway,
Yes, that's right. Norway. That's right.
and it's a
yes,
very amazing. I'm so happy with with this because it's so Java expand around the world with international talks, international speaks, and it's a great pleasure. We have more one Java champion here in talking to Java.
yeah.
Thank you very
It's
much.
amazing.
Yeah, go ahead.
And
Yeah, and
Rust,
you.
go ahead, Max.
Oh, okay, yeah. So I'd like to say to people in the chat. So feel free to send the questions and don't care about the language. If you want to speak in Portuguese, go ahead asking, and we will translate to Rustin, and probably Rustin is a kind of one. So if you want to asking him about everything about development software, so he's amazing to want to clarify the ideas. So last time that I talked with Rustin was I think last year. He talked about cloud application, cloud software, cloud solutions. Am I right, Rustin? And today we talking about non-functional funds things. So I'm very excited. So thanks again, Rustin,
Thank you very much.
for having us, for joining us. And Gabriel, I pass my word to you, and let's Rustin get started. Am I right?
All right,
All
Rustam,
right.
this is your time. Thank you so much to accept this invite and giving this talk in Soul Java. All right.
Like I
We will
said,
be on the backstage.
thank you all for having me. It's really great to be here, to be joining all of you. I understand it's afternoon for you guys. It's a bit late in the evening. Well, it's not late in the evening. It's like, what is it, 5 o'clock here in the evening. So it's a little bit easier for me. But to the rest of you, I hope you're having some nice lunch and listening. And I'll be talking about some cloud stuff this time as well, but from a little bit different perspective. So it's still going to be cloud native applications, will be Java applications as well. So um, what else? Yeah, if you have any questions, feel free to ask them. How are people going to ask questions? Is it in on YouTube chat or is it somewhere else? How does this work?
They will send the questions on the YouTube channel
Oh, perfect.
on the
Yeah.
chat, and if you I don't know if you are able to see the
Yes,
live chat.
I can see it, and I just said hello to everyone, so then you can see that the chat is on, and then if there is anything, please ask questions, and I'll try to keep an eye on them and ask them right away. Sorry, answer them right away as you ask, and then if not, then we'll do it at the end as well. So it doesn't matter. It's both things work. And if not, then we can do it offline as well. There is my you can see on my screen right now on slides that I'm sharing. There is my Twitter handle. I'll also share a link to all the other social media handles later, so then you can actually find me offline as well and ask questions. so that should be fine. All right. Um, we get started.
Yeah, got it. So let's be on the backstage, Gabriel, and let Rustam do his show.
Perfect, Max.
It's always fun to do presentations online, and it's a bit hard to do it online as well because it's just me looking into the camera lens, and I cannot see all of you that are on the stream and everyone. But you can still communicate and ask questions and do things, and then we can get it going. Let's see how this goes. So I have some code, I have some presentations slides. We'll be switching a little bit back and forth, but for now, let's start with a little bit of presentation and give you a little bit of background of what's going on and what we will be talking about. So a little bit of introduction. Well, first of all, my name is Rustam, and like the guys introduced me, I live and work in Oslo, in Norway, and I work with architecture, with cloud, with Java applications, and as an advisor and consultant, things like that. So I'm also a Java champion and Google Developer Expert for Cloud. So there's you can probably see there is a theme going on. It's all about Java and cloud and things like that. So things that I really want to talk to you about is more about I'm 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 going to be talking about Java. I'm going to be talking about Jakarta E, as you can see on the screen. But a lot of those things you should be able to apply to uh, many other even languages, but also things that are on JVM, like things like Kotlin and things like that, and also other frameworks and libraries. So I'm going to be talking about Jakarta E. I'm going to be talking about some other stuff, but general concepts that I will be explaining and I'll be going through, you should be able to find in any other thing, whatever you might be using, if you're going to go with a Spring Boot or Micronaut or any other things as well. So to give you a little bit of a context of what I'll be talking about and what Jakarta EE is, I usually ask people in the room and say, hey, have you heard of Java EE? And there will be some hands, quite a lot of hands. And then I will ask them, hey, have you heard about Jakarta EE? And then there will be some other hands. And then it's kind of funny to see that it's actually the same thing, but people know it by different names, and they not always know that's actually the same thing. So I like to start this by showing the little bit of a history and evolution of what Java EE used to be. J2E, it used to be known as well. Now it's known as Jakarta EE, and also some features that's been added throughout time. Um, so right now it's called Jakarta E. Now the latest version for now, for not so very long, but still for now, is Jakarta E 10. And it's been collecting all those libraries and all those things and extra features that plain Java didn't have, but you could add those things on top of that to make your applications more enterprise ready. And back in the days, we would have things like I don't know if any of you remember things like SOA, server oriented architecture, service oriented architecture. Sorry, and then. We had things like soap and all those things. Now all of those gone. Now we're doing microservices. Now we're doing REST and grpc and all this kind of things. And still a lot of those things you will find in Jakarta EE nowadays, right? I'll explain a bit more what I mean by that on the next slide. And then here you can actually see that the part that is grayed out is the whole Jakarta E platform. It's a very big thing. It has everything from authorization and batch processing and emails and messaging and all this kind of stuff to transactions and bean validation, all those things that you probably have heard of if you worked on enterprise Java applications before. But this is not going to be the kind of the topic of today. The topic of today is going to be the thing that you actually see in color and clear. That's the one that is the smallest piece of it. of Jakarta EE platform called Jakarta EE core profile. So you have core profile, then a little bit bigger chunk is a web profile, and the whole one is called, well, Jakarta EE platform, right? Um, so what we're going to be talking about today is this little piece called core profile, and that's kind of things that typically you would need for your own microservices, for creating modern cloud native applications using Java and all this kind of modern development, as opposed to the way we used to do it back in the days, where we would create one big monolith full of features and libraries and all that, and just deploy it on one big server somewhere that would just scale vertically and won't be easily scaled horizontally, and everything would be just very tightly coupled and just put together. Now it's different. Now we have microservices. We talk a lot about that. We talk a lot about cloud native, serverless. We talk a lot about loose coupling, all those things. And this is what core profile can help you with. In addition to that, there is a few other things that will make your Java cloud native applications more modern and more responsive, better, all those kind of things. And that is a few other things that come on top of that. So we've seen core profile, that's the yellow box down here. But now we have also a few other boxes on top of that as well. We have things like telemetry, open API implementations, and everything that is things like Swagger and all that are built on top of REST clients to be able to communicate with other services, to be able to communicate with other RESTful endpoints, config, fault tolerance metrics, all those things that we'll be talking about. Most of those things actually we'll be talking a little bit about today. And this is where what I call non-functional requirements come in. And what I mean by non-functional requirements, well, typically when you have to implement an application, it's you get a bunch of functional requirements. Your application has to be able to do this and do that, and to create this functionality for users, and do this for your customers, and so on, so on, so on. But nobody tells you that, hey, you know what? You have to create an application that has fault tolerance. That's not often a part of the requirement. That's part of creating resilient applications. Or your application has to expose certain metrics. Maybe it will be written as requirements, but most of the times it will be kind of non-functional requirements. It will be written as requirements, but not functional non-functional requirements. It's kind of important to separate those as well, right? So yeah, what I'll be talking about as well is microprofile and things that are part of microprofile, but they're both part of Jakarta Eclipse Foundation, and also built on top of Jakarta E10 core profile as well. All right, that's a little bit of introduction. And another thing that's worth mentioning here, and it's important to think about when I talk about both Jakarta E and microprofile, is that both of them are actually specifications. So it's up to providers who claim to be compatible, who say they're compatible. It's actually to implement those requirements and those specifications, and actually have their own implementation of that. And that's what we see. We have seen different implementations, different runtimes that are actually able to provide this kind of support for all these features and functions for users. There are a bunch of them. We'll talk a little bit about that as well in a bit. Okay, so I promised you 5 things, right? And 5 things it will be. The first thing that I want to start with is fault tolerance. I want to see somebody saying hello, Edel. Fault tolerance. So what is that? It's basically what happens to your application when something fails. Because how do you handle actually errors, right? You created an application, it's fantastic, it's providing all this functionality that you need to provide to your customers, they are really happy, but this is made for hello Jefferson. And but then you're actually creating your application um, for a happy day scenario, right? So happy day scenario, everything works, everything is fantastic, everything is behaving as it should be. But what happens when something goes wrong, especially in a service that you cannot control? Maybe it's somebody's else third party service. Maybe it is your own service that's a little bit unstable, or maybe it's super stable service, but one day it fails. How do you actually handle that? So this is what fault tolerance is about, and um, what I mean by that is, like I said, your application crashes if something fails. That's probably not a good idea, right? It should not be able. It should be able to handle that, and it should not just crash out of nowhere. Um, if it happens, because it's not a question whether it's going to happen or not, it's basically a question of when it's going to happen. So when that happens, you need to have a plan B. And plan B is to be able to switch to another solution. Of course, you can program it yourself and just do all this pings and checks and ifs and else's and all that yourself. But you shouldn't be forced to do that. You should be able to actually um, you should be able to use a library for this kind of things and just uh, make it available for your application relatively easily. And most, like I said, most of the frameworks that we have that we're using, they do provide it in one way or another. So here I'm going to be talking about the spec that is a part of microprofile fault tolerance specification, but you should be able to find similar things for other frameworks as well. So if you're not using that, well, give it a try. If you're not wanna if you can't or don't want to try that and you're using something else, look for something very, very similar. It should be there as well. So what do I mean by this? Well, in the way you do it in microprofile fault tolerance spec is that you do it with annotations. So you can actually use this annotations to provide things like timeouts, to provide things to how retries should be happening. You should be able to provide also ways to be how to fall back to another solution, to another method, to another endpoint. You can also provide circuit breakers and all this kind of things. So circuit breakers, why do you need that? Well, if everything fails and you've used up all your fallbacks or you've used all those retries, you want to be able to kind of actually have a circuit breaker that will finally kill all the retries and say, you know what, we've tried everything, that thing is not responding, we've tried all the other things, that's not responding either, now we're just gonna leave it for now as it is, and then circuit breaker kicks in, gives some kind of error, and that's probably, in my opinion, it's probably kind of the last resort kind of thing, but usually you need it not to DDoS the applications that you're depending on and that you're trying to reach and that are not responding the way you expect them to. Um, I'll show you a little bit of static code, if you can say that. I mean, I'm going to show you some screenshots first, and then I'm going to switch to actual live code and an IDE as well. But for now, what I'm doing here, it is to create two interfaces to another service. So this is my application that is dependent on two endpoints in another application, and the main endpoint that I depend on and I'm using is called message, as you can see, the first one. And also I define what kind of endpoints or back response I will be receiving. So I'm just saying produces application JSON and all this kind of stuff. But here it's the most important thing to note is probably the path. That is, well, it's going to be at slash message, but also at fallback is the another thing that will be used here as well, which is a reference to a method that will be called if whatever that implementation of that interface, that method called get that data. If that fails for some reason, probably because of the other endpoint being not responsive, we need to provide a pointer to another function that will be our failover function. Another thing that's probably worth mentioning here is that I do actually register a REST client on top. So I'm saying I'm going to have another REST endpoint that's going to run on this URL, so localhost 8080. That's for the other endpoint that I'm going to be reaching. And on that localhost colon 8080 slash message, there will be something that I need. If that fails, go over to another method, right? Implementation on the other side of what I will be trying to reach will be like this, right? So I have a slash API message, which will return a message saying hello there. And to make sure that I have a little bit instability in my service, just to be able to show it and to be able to show you how failover works, I introduced a little bit of randomness into the whole thing. So I roll a dice. If the whatever dice shows, the regular game dice, the six sided dice, and if anything that shows up on that dice is divisible by 2, it's success. If it's not, then we create some kind of weird error. It says actually literally some weird error at the bottom there, and I actually do return a server error. So 500 something error saying, well, some weird error happened. And my backup message will be returning a backup hello. And that way I will be actually able to see which of the services I am reaching. So I will have another service trying to reach those 2 endpoints at some point. And the way I do that, well, with fallbacks and all this. Another thing that I want to show you, I'll show you this everything live in a little bit. Let's talk about those 5 things first, and then we can go through some live code out at the end. Another thing that I really want to talk about is health. So health is a bit different animal, right? It's a bit more about showing what is inside your application, how things are going on inside your application. And it will tell you what's going on inside the container, because we're talking about cloud native applications, we're talking about serverless applications, we're talking about this new modern microservices and all that, and most of the times they'll be living somewhere far deep into the cloud in some kind of container inside another virtualization level inside of something, and you should be able to actually check how those applications are doing. And you need that for several reasons. So one of them is obviously liveness checks, like checking, hey, are you alive? Are you still okay? Do I need to clear that container and create a new instance of the container? And just in case you're not doing that well, I'll just create another one and make sure that one is fine. That's one thing. That's kind of the most obvious thing. But also there are things that you can you can use that for scaling, and you can also do that for knowing when your platform, whatever you're running on, it could be Kubernetes, it could be Knative, it could be some other serverless stuff, that your platform is able or should be able to route some traffic to your application. Because if your application is not ready, you need to wait, and to be able to know when, that's why you have those probes. So you have readiness probe, you have liveness probe, and you have all those things that we'll see on the next slide. So readiness, startup, and liveness. Because think about it, like when you start a container and you start an application, it's not just like in a good old days where we would just have, I'm not sure how good they were, but old days, where you would just start, you would have a server running some kind of operating system. On that, you would have an application service, whatever, a server, whatever that is, Tomcat, JBoss, whatever. And then inside there will be running an application, and that's it, right? You know that it's ready, you know it's started up. Maybe you have to wait for a bit in the beginning, but then it would be just running and will be fine, right? Now your containers can die at any point. They should be probably without any state, so stateless containers. They can also be running on some preemptible instances that can be killed and restored at any time, or they should be able to scale horizontally to many, 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 many small instances of the same container image. And to do all that, we need to know, is the container that we're using, is it ready to serve requests? Or do you need to know if the actual container started up, or if the actual application inside the container is started up? Because think of what's going to happen when you start a new container in the cloud. It's first you need to find the right image for a container, right? You pull that, you copy that image, then you need to execute whatever the application container says in its startup script. So you need to maybe download some things, maybe build some things, maybe copy or start up some things. After that, you need to, before that happens, your container has to start up, right? So actually container startup time. After container startup time, you need to start your application inside the container. And when that is done, it should be able to tell the platform saying, hey, now I'm ready to actually receive requests. I wasn't ready before, now I am. So startup probes and liveness probes are also very, very nice and useful, handy things, because after your container has been running for some time, maybe something happened to your application, maybe something, you have some kind of memory leak, or maybe something else. You don't know. But if anything goes wrong, your liveness probe should not be responding the way they should be responding if everything is fine, telling the platform to, it's time to kill this container and create a new instance of it. So again, this is a specification. This is a specification from Microprofile Health, but you should be able to find very, very similar ways of doing that other places as well. It will also expose it on the typical, more or less standard URLs for you, and you can point those to those URLs inside your platform if you're running on Kubernetes again, or serverless or whatever. You can tell them where those URLs are, and very typically it's /live /ready /health/live /ready /startup, and all those kind of things. Right. Let's talk about something else. Let's talk about not just checking if things are good and ready and all this stuff, but let's talk about how to measure some very, very, very application specific stuff as well. So now that we have a fault tolerant application, it can respond to all the errors that might happen to it, because you've coded everything with fallbacks and retries and all that. You have also created a bunch of useful and meaningful metrics health checks to make sure that it's ready and live and all that. Now we can actually expose on a standard endpoint in both machine readable and kind of human readable way as well. And as a standard way of exposing that, we can actually expose custom parameters or custom metrics. That metrics will be specific to your application. Some of those things will be just standard things that all applications might have, but some of those that you can actually also create your own ones. And then you can, for example, count. I mean, the easiest will be probably counting how many times some kind of endpoint is being called, or how much memory you're using, or how much, I don't know, how much time you've been processing some kind of document during the day, whatever. It can be anything, really. But the way you do that is, there are many ways of doing that. So one of them is just to count, right? That's the most basic thing. That's the most basic thing we learn as when we get children, as when we grow up, when we're children, just like 1 apple, 2 apple, 3 apple, and so on, right? Same thing here. You can do counted endpoints. You can just do at counted. You give it a name, what it should be. You give it a number of tags. What tags can be applied? You can actually apply different tags to the same to an attribute or annotation of the same name. But you can also say if it's going to be absolute or not value. There are a bunch of other ways of doing that as well. I'm gonna leave you with the link. You can see a tiny little link at the bottom there at the end at the right bottom corner of this presentation as well, and that's goes actually for all things that I'm showing. But again, anything else that you might be running on, you should have some kind of metrics, ways of exposing metrics as well, without having actually to write all that. Because if you had to implement all that, right, you would have to implement all the calls, all the counting, all the everything, test everything, that everything works, and do all those things yourself. And you don't really want to do that, do you? Here it will be actually exposed everything at /metrics, and we'll see that in a second as well, how it works and everything. Thing number 4 that I want to talk about before we go to the demo. Thing number 4 out of 5. So we have 2 more, right? It's feature toggling. So this has nothing to do with Jakarta E. It has nothing to do with microprofile and all these things, but it's a thing that I really want to encourage you all to use. And here, again, use any tool that you want. Use any framework, library, whatever you want to do this. Piece of software. Just my message here is just pick something, use it and enjoy it. Don't try to do it yourself, because it's a bit painful to implement it yourself, and you don't really want to implement it every time for any application that you're developing. Why would you want to do that? Well, there are many reasons for this. One of the reasons is that you just basically have a bunch of features that you want to make available when you want, without need to deploy a new version of an application. So you can actually deploy an application with all the features that you wanted but turned off. And then you can just sit there in your control room and say, you know what, now it's time to reveal feature A. And then you just click on it. It just makes it available in your application without really need to redeploy and things like that. Another way of doing that, or another reason for doing that, is that maybe you want to create features that are only available to people within specific geographical areas. So maybe everyone in Brazil should get a background of one color for the website, or everybody from Norway should get, I don't know, polar bears in the background. I don't know, anything, right? You want different features, you want different things based on geographical IP location, IP addresses, or maybe you want to hide some features that are not really done yet, right? It can be, let's say, for example, your front end you have implemented a feature in the front end, but the backend people, they did not implement it just yet. It's still not done. So what do? Do you have to remove it and delete it from the front end, from the main branch, and wait till the backend people are done? Or you can just add a feature toggle there and just remove everything with a feature toggle, and just wait for the backend people to deploy a new version of their service with the features that you will be using on the front end. And when everything is ready, you just flip again a switch, and the front end features will be available, and we'll be able to connect to the right backend as well. Another thing, so we mentioned turning off and on features. We mentioned partially implemented features. What I didn't mention yet, probably a good idea to mention, is, for example, that you can do partial gradual releases. That's also another really nice way of providing features gradually and test them on some users. So you just make features available to 10% of your users. Only 10% will be able to see it. Other 80, 90%, if we're doing 10, they will not be able. They will still use the old version. And then if everything goes well and there is no errors, you can maybe increase those 10% to 20, and then you'll have 80% using the old version. And then you can gradually do that. That's really nice. Thanks for the comments. That's really, thank you. I see the comments running in, and that's really great. And do the same with the questions. If you have any questions and stuff like that, do the same. All right. Let's go back to next slide. So feature toggling is really nice, right? And it has useful applications and all this kind of things. How do we do that? Well, you can obviously write it by hand. You don't want to do that. We talked a lot about that because you don't want to do it every time. You need to test all this and, all these kind of things, right? But you can use a tool. There are a lot of different tools. So I just had to pick one because I wanted to build a demo. So it would be like very difficult to say, you know what, there is a million of tools, so I couldn't pick one. So I'm not going to show you a demo. So I had to pick one. And I ended up picking something that is that has an open source version. I mean, they do have their own cloud and stuff, but this is different. This is actually open source version. It's called Unleash. So they have their own GitHub where you can just pull down a bunch of containers and just make them run on your own hardware and everything if you want that. So that's one of the reasons why I picked that, because it is free and open source. And the other reason for doing so is that it was made in Norway. So, it's just kind of weird, weird way of in a sense promote. I'm not really promoting, but still kind of promoting local stuff. And again, I'm not promoting anything. It's up to you what you want to use. This is just what I ended up using. Another way of doing that, by the way, without using feature toggling systems, is putting in a config file. The downside of putting into a config file is obviously that very often, most of the times really, your applications need to be restarted to actually consume that config file and to start using it and to start updating their own versions of variables that are in the config file. It usually doesn't happen until you actually restart your application, and you don't want to restart your applications, right? Because you're cloud native, you're running a bunch of them, and you don't want to restart every one of them, and all those things that we talked about. So in my case, the way you do it is like this. So piece of code that looks something like you create an unleash object. I do that in a constructor for this method a bit further up. And after that, it's very, very standard. I'll show you how it is. It's very standard. You just provide a URL, provide a username and password and stuff like that, and maybe provide a key or whatever you want to any way, somehow, the way you authenticate towards your feature toggling service. And after that, you just say that object. In my case, that object is called unleash, and it just says unleash is enabled, and then I check for a variable. If that variable is enabled, it will return me true. If not, it will return me false. If it doesn't exist, it will still return me false. So it's really nice and handy. So as you can see, this is a upper what's that, left corner. That's a piece of code how you do it in your application. And on the right bottom side, it is the actual web interface for that feature toggling service, where I'm just saying, you know what, this thing called chaos, as you can see in the corner, it says chaos. That's the name of my variable. And that's the same name that I check in my code. If chaos is enabled, and I can see down here that it is enabled for development environment, but not in production. So if that's enabled, do some stuff. And that's it. I'll show you it live. It's kind of fun. And it's really cool. The thing is that Most of those systems like this are um, they're very responsive. You just switch it, flip the switch, and within just a few seconds, it's already available for all. It's been already pushed to all of the places where that variable is being used. That's really cool. There is one downside, though. Before we go to the next slide, I want to talk a little bit about one downside of doing that. And that's like with everything else. When you add feature toggles, please, 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 please do remember to remove them. Do not leave them forever, because when you don't have use for your feature toggle, and you probably should not have a feature toggles, most of your feature toggles probably shouldn't be living forever, and by the time you don't use them anymore, you have to remove them. Add whatever you want. Add like to-dos with expiration dates. Put create issues to remove them. Do whatever you want to do. Just make sure that you actually delete them when it's time. Because otherwise, they will stay there and they will rot there. And after some years, people will not dare to remove them, and now you have a lot of feature toggles that nobody knows what they're doing, but nobody dares to remove, and that's a bit bad, bad practice. It's a very good way to get a lot of headache. It's a very good way to get a lot of weird technical um, uh, garbage, basically, and don't do that. So if you want to leave this presentation with anything, this is one of those things, and the other one, it will be coming on the next slide right after that. So at least 2 or 3 things coming out of this presentation. One, do clean up your feature toggles, and number 2 uh, is just coming in a second. I'm just going to leave you for a second on a cliffhanger, so you just wonder what's going to be, because then you'll remember probably better, I hope. But now I want to talk about things like environments, configuration of your application, infrastructure of application. That's also part of non-functional requirements, because most of the times there will be a lot of focus of what your application should be doing, but not that much of um, how it should be deployed, how it should be configured, what infrastructure it should run on, and things like that. Let's talk about that. Before we do that, this is the second thing that I've been talking about. So it's going to be revealed very soon. Drum roll, everyone. Very important thing when it comes to infrastructure. It's super important thing that is. I cannot I cannot stress how important that is. Do not even think about doing ClickOps. If you don't know what ClickOps is, it's probably a good thing. If you do know what it is, you know what I mean. And if you don't, I'll tell you. So ClickOps is basically going into the cloud providers or your platform's web interface and doing click, 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 setting up things in the UI, forgetting what you did, having no idea how you can do it again, or thinking that you will be able to do it forever. And I promise you, after like a month or 2 or 3 or 5, depending on how fast you forget things, you will be scratching your head saying, I need to do a new version of this thing, but how is this thing again? It just doesn't work. I just forgot. I don't know. So do not even think of doing ClickOps. Please, please, please don't do that. If you want to deploy applications in a predictable manner, in a good way, use some kind of infrastructure as code. So for infrastructure, it's infrastructure as code, things like Terraform, Pulumi, and all this. For deploying your applications, it might be different. Maybe you have some kind of deployment scripts. Maybe it's a part of your CI/CD pipeline and all this tools that you're using. Or maybe you need to create your own. Maybe it's Ansible. Maybe it's something else. Maybe it's just a plain good old bash script. Whatever. Just do it as a piece of code that you can version, that you can control, and you can actually keep it up to date. So why do you want to do that? Well, one, it's reproducible. You can always run the same script and you'll get the same result. 2, it's actually documented, because now you have a documentation of what has been done, how it's been done, and next time uh, people can have a look at it and know what's going on. um, Third thing, which is kind of obvious, but I'm going to say it anyway because it's automated. We all love automations. As developers, we actually love automation. Some of us, including this guy, have spent some. I mean, we are probably, a lot of us at least, are guilty of spending a lot of more time on automation, automating things that actually should have been easier to create manually. But it's so much fun to automate it. But I'm probably going to use it once. But so we've done this, right? And we've gone into this, um, a trap, time trap. But very often we forget about that, and we end up doing a lot of manual work over and over and over again, and just forgetting about that. Hey, it could have been actually automated. It could have been it could have saved us time, but it can also, automation is also very, very useful for making sure that it's been done. It's being done in exactly the same way without any human errors involved. Because we humans, well, we do make mistakes, like it or not. That's how we are. That's how human nature is. We do make mistakes, even though we think that we never do. Um, right. So that's the good things. Bad thing about the whole thing is that it needs to be automated. It needs to be maintained. So, you need to spend a little bit of time automating it. That's fine. That's one thing. That's a bit more extra time. But the next thing is that it's not just write once and forget about it. You actually need to maintain it from time to time. Things might break. Your new versions of your operating systems, or new versions of your CI/CD pipelines, or deployment tools, or cloud providers, or containers, or libraries. Something will change and something will break something somewhere, and you will be tempted to do click ops and fix it just to make sure that you put out that exact fire right now. Don't do that. Try to fix it in the code, in the systematic way, and then run that code and make sure that gets deployed, right? Right. So with that out of the way, we can actually talk about other things. We can talk about, I mentioned already, infrastructure as code, things like Terraform, Pulumi. There's a bunch of different forks and stuff that is how has been happening lately. So now we have all kinds of tofu and open tofu and all this that has been forked from Terraform repositories and all this. Pick one, use it, and just keep using it and keep maintaining your configurations. It can also be, like I said, it can also be application or more on the operating system kind of level stuff for deploying things. It could be Ansible playbooks. It can be something else, right? Yeah, that's about infrastructure, deployment, things like this, right? Now I want to talk a little bit about config. So for config, there's usually something that will handle configuration files, those .property files typically. There's also some kind of library that should be able to handle the hierarchy of those property files, because typically you would have one property file that's specific for an application, one property file that's specific for an environment, one property file that is kind of the ruler of them all on top of all that and can overrule all of them. But it will depend on what you're using. It will depend on what kind of library you're using and all that. Here I am mentioning microprofile config, since I've been talking about microprofile already, so I might as well do that. But again, it will vary on if you're using something else, but it should be something there. And also think well about your hierarchy of your property files as well, or config files, whatever they are called. Another thing that I want to mention is infrastructure. And infrastructure, by infrastructure, I mean how you deploy your applications on what. Are you doing infrastructure as a service? Are we doing basically hardware, right? Are we doing platform as a service, things like serverless and all that? Are we doing VMs? Are we doing just a plain old, good, old, you know, a virtual machine that running somewhere in the cloud with operating system, with all that, and you just install and deploy things on top of that? It can be good, reasonable requirements that will make you do that, and that's fine. The only thing I'm saying is that you need to think about and think really well about what you deploy it on. And if you want to go, let's say Kubernetes, fine. Maybe you have a use case for that. If you don't, if it's just because you're doing it because it's cool, maybe you should try serverless. Can your applications handle serverless? Can they be scaled to minimal number of containers, maybe even zero, and scaled up again? Can your applications do that? Can you provide your application with just regular standard hardware and will run because virtualized standard hardware? Maybe your application needs a super specific hardware. Maybe it needs like graphic cards or special kind of disks or whatever. Then you may need VMs. You need to have something that is required by that. So think about all that. And if you go serverless, it's not only just amazing and fantastic as well. Sometimes you need to think about the complexity you're introducing, right? So think of it, you have a bunch of serverless applications and you deploy them all into one project without any system, and then you have 100 functions that are out there, and you have no idea how to get list them all, to make sure that they all run, to make all these things. It can get very complicated. So be careful, think through it. I'm not going to give you an answer because the answer really, really, really depends on what you're doing. But have a good idea, spend some time and have some good arguments against and for doing something, and also ask others and see if they have some ideas. Ask architects, ask tech leads, ask your colleagues, whatever it is. All right. I added some links to the things that I mentioned at the end, at in the corner there as well. If you want to have a look at different products or specifications that I'm mentioning, you can do that as well. So now it's about time to do a demo. And before I do a demo, I want to show you a little bit of architecture. So this is the demo architecture of the demo application. So technically, like I said, I have two different small services, two different tiny little applications. I call them Service A. Yeah, good that you love demos. That's really nice. It's coming. And I mean, to kick off the demo, I'm actually showing the diagram of the services drawn in ASCII. So this is actually pure ASCII art, just saying. To all of you geeky people out there, you probably might like it. I have a service A, I have a service B. Service A has exposing two endpoints, saying endpoint high and endpoint feature. The high endpoint is responsible for getting hold of an API on service B. An API on service B is consisting of two different endpoints. Again, it's a message and backup message. We've seen those, right? So now I have also the third service, which is a feature toggle service, where I can actually toggle several features. So two that I mentioned here are feature and chaos, and I have one more, but we don't really need to think about that for now. And depending on toggles for those features, thing will be different. Right. Okay. So now let's see. Yeah, so this is a slide that you can, I'll show you this slide as well. I'll probably show it at the end after demo again, but this is how to get hold of me. And all the source code that I'll be showing you right now is in that URL there. So it's open on my GitHub. Take a screenshot, type it all, or if you don't want to type it everything, go to the to my website that I'm linking here, rustam.no, go there. There will be a link to GitHub. From there, you will actually find this repository called 5 Features Talk Demo. Right. Okay. Demo time. Let's see. Can I do? Yeah, I can do that. That's great. What I can do is to show you some code. What's the best way of doing? Okay. Before I do that, let's see. Localhost. Cool. Share this tab instead. So now you can actually see my, let me zoom into this thing. Yep. Okay, good. So this is my web service, and maybe I should be, let's see, share screen, share a window. I can do this and share, because then you can actually see the whole URL. If I, how do you do that? Can you guys switch my, let's see, maybe I can do this, remove share. Okay. Can you make it a little bit bigger? Yes, thank you very much. I have a fantastic two guys doing all the hard work in the background. Thank you very much for that. All right. So, and now you can actually see the URL. So, and you can also see, let's see, GitHub, GitHub, let's see, 5. There it is. So if we go to the README file here, you'll see all the URLs that I'll be using. So now I'm on 9081, and it's the hi message, right? So I keep on saying this. And now you see what happened? I actually got a backup hello, and it keeps on happening sometimes it does not. And why is that? Well, that's because in our backend service, we do have flickering service, right? So if you go into Java and demo app, you will see that here is this piece of code that is doing all the flickering stuff. Again, because we have unleash chaos thing enabled, and because sometimes we roll a dice that is not divisible by 2. Let's have a look at localhost at our 4242. Let's look at our unleash server admin. It's always fun to do live demos because they are always a little bit scary. Let's see what we have here. We have projects default. I need to zoom out of this thing. Yeah. So I have a variable called chaos, and it's turned on. So if I turn that thing off and I go back to this tab, no matter how much I refresh, it will never become a backup hello. Now, if I turn it back on, which one is it? Chaos, yes. And then now at some point it will start failing again. Now I'm refreshing, you can see this blinking. Now it's back up hello, right? So this is failover, and the way it works, like I told you, there's it's basically, this is my failing endpoint, and the reason it's actually being able to fail over is that in my demo service, or kind of front end service, I have Java demo app. Inside here, I do have failover specified. Sorry, not here. Wait, where did it go? There, here it is. So I have a endpoint that is being exposed at VS backend 8080 because it's inside a container, because I'm running Docker Compose right now. And here I have specified a fallback method. And when my first method, my message endpoint fails, it just goes on to this. Right. So that was failover. The second thing that we talked about was health. And the way you can do health, you can actually go to /health, and it will give me all the liveness probes and readiness probes and startup probes and all that. I'll zoom in so you can actually see what's going on. Yeah, there you go. We can even pretty print it or not. Doesn't matter. Yeah, I mean, it's pretty printed enough, right? But you can also do, the cool thing you can actually do is to actually go, for example, /live, and it will only give me liveness probes. Or you can go start it. It will only give me startup probes and stuff like that. The cool thing is that right now it says status up, everything is up and running and everything is fantastic, right? But I can create, let's see if I go back, if I go into my markdown file where I have all the links. So you can actually do, for example, liveness checks on response time. So if your application is too slow to respond, you can actually do something with your liveness probe and say, hey, you know what? This application is no good. We need to create a new one. We need to kill this container because something is becoming very, very slow. So if we look at this one, we actually have a check here. So this is my implementation of liveness probe. I did it with @liveness. It's application scoped and it's a class. So I'm implementing here my own liveness probe, and I'm saying if the endpoint is responding for in less than 3 seconds, it's fine. If not, then it's failing. And I've been cheating a little bit. So I created my own little chaos delay variable. So if I turn on delay, that will make all my endpoints respond within, I think, 5 seconds or something. I sleep for 5 seconds and then I send a reply. So now, guess what? If we refresh this, it will be spinning. You see it's spinning up here for some time. And now it's returns you the information saying, you know what, the liveness check of response time, which I actually gave it myself, and I told the name of this thing. Let's see. I defined it here, and here, see, health check response named health check response time. And I'm saying, you know what? It's too slow. So critical service /high, that is my super important service, is too slow. So we're not good. And, it will happen every time I refresh. It will be just down. But if I switch and toggle my features, turn off the delay, magically that thing will start working again. Probably not right now, but next time I refresh, because, there you go. What do you know? We're up and running. Right, so that was that. Now I want to show you some metrics. We're almost done. I want to show you the metrics. That was the third thing that we've been talking about, right? We talked quite a bit already about feature toggling, so that's the fourth thing. So we did a little bit of jumping back and forth, but that's fine. You see this wall of text? This is actually a really, really cool thing, because most of those things that you see here are standard things that will just follow you the moment you expose your metrics endpoints. But if we go to 9082, that's my backend service. It has also metrics, but it has a few extra custom messages, as you can see here. Again, let me zoom in. So you see, as I've been showing it to you and refreshing this application, I already called my high method endpoint 125 times. Out of those 125 times, I actually failed 32 of them. So I had a failover of 32, and that's all is being counted. And the way you do that is, let's see, the way you do that is basically, this is my delay function, by the way, in case you wondered. And I did sleep for 5 seconds. I did not lie to you. Here's the proof. But what I want to show you is, let's see, custom metrics. Where is it? Yes, there it is. You see, I am doing this custom message service, absolute value, and it's true. And this is for message. And I do the same thing, exactly the same thing for backup message as well. But I do give it another tag. So purpose failover here and purpose total here. And this is what happens here as well. So that's what you see here, purpose failover and purpose total. So it's pretty magic, right? You just do a few annotations and everything just works out of the box. And again, this is microprofile, this is a RTE, but you will be able to do the same thing in whatever you're using. If you're not able to do that, there's something probably wrong with your application. I mean, don't quote me directly on that, but maybe you should have a look at something else. I'm pretty sure that most of the frameworks that are out there have this in one way or another. Right. Okay, let's go back to so what you can look for in my repository is to look for this little wiki markdown file, which has all these 5 different features with the links and all that out there. That would be very, very nice. Oh yeah, I will show you feature toggling. I showed you how it works in practice, but I want to actually show you how it's being, well, at least easy way of defining it. So what I do here is that I actually do it the way you're not supposed to do, because this code will be committed into a repository. And if your endpoint is public, right now it is not, right? Because it's running inside a Docker Compose and all this stuff. But if your endpoint is public, you should not commit your code with your API key inside there. It's a big no-no. Don't do that. In this case, it's fine because it's local and it's demo only and it's not running in production. All those reasons, but don't do that. Do not do that. Promise me you don't. You will not. But the point is, you create an app name, you create an instance ID, you create a blah blah API endpoint URL and a key and all this, and now you can just start using it. You can just say now unleash is enabled and so on and so on. Right, so that was it. Have a look at the README as well. It explains a lot and explains how to run everything. I do mention here Podman. I do mention here Docker. I've been running it on Podman and Docker, and now I'm running everything on Kolima with Docker Compose on top of that, and it just works. So it should work for all of those things. And the other cool thing, if you really want to understand how things work in Docker Compose and you haven't played around with that as well, I can show you some fun things here as well. One of them is that you can create your own network and you refer to it, because I had an issue because I had to start 2 Docker Compose instances to be able to run a bunch of 2 containers doing all the feature toggling service. And I wanted to run my own containers, and I wanted to have them into different Docker Compose files. So I had to create a network, because otherwise they would not be able to see each other. They would be on different subnets, on IP subnets. So to do that, I needed to create my own network and do this. So I created a network called Unleash Default, because that's what Unleash creates, and then I just hook onto that network as well. That's one thing. And the other thing that is kind of cool is that you can create dependencies. So you can actually say, where is it? Yeah, you can create health checks. So you can say, you know what? You're not supposed to start until this service, blah, 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 is started. And you're not supposed to say you're actually okay until this responds with a good, with 200, HTTP 200. And then my web service that I call for a client service, VS client one, is actually depends on backend on a condition of being service healthy. So basically what I'm saying is that my client, my service, one service is dependent on response from the health check from the previous one. So it's also kind of cool things. You can actually create those kind of checks and make sure that things will not start um, until everything is up and running. If things are depending on each other, I have the same check also for Unleash. So I have external links to Unleash Web. And if Unleash Web is not responding, I will not start. This will also fail and say, hey, you know what? You haven't started the Unleash thing. So it's kind of cool. It's outside the topic of this talk, but it's still a bit fun to have a look at that. And also you can have a look at all the fun things I do in Docker files. And this is kind of interesting how you build and how you do gradual deploys or sorry, not gradual deploys, but multi-stage deploys, multi-stage builds in Docker. So here I'm building everything, all my code with Maven. I throw everything away. I create another container, move all the important stuff into it, and then I just run it and make it available. And that's kind of I don't have to run anything inside my machine. Just everything is being containerized and built and everything. So it's kind of fun. Yeah, so there is a lot of fun things that you can have a look at, and each of the folders has their own readmes and so on, so on, so on, so on. Right. I think it's it's enough of the demos, and I don't see any questions coming in the chat. I just see a lot of people clapping and saying great content and all this, and it's really I'm really happy to see that and happy to see that you enjoyed this, and thank you very much for very nice words. And again, thank you for you two guys as well to for hosting me, for inviting me. It's great pleasure to join you today. Yeah, that's
That's amazing, Rustan. So please send us the link that we will share on the chat.
oh yeah,
We
I'll
put
share
on
it. I'll share
as
it.
your
So the easiest way to find everything, all content, is to go to let's see, is this Rustam.no? There, I just created, this is like a link to all of my things. It's just a collection of links. It's linked to my blog, it's linked to my social media, it's all this kind of, it's all the collection of links. And my GitHub is there as well. So that's the easiest way, is just to go there, and it's easy to remember as well. So you can just go there and grab all this. So
amazing
we can do it here
Rustan
as
dot
well. So you can actually,
no. Okay,
yeah, so if you get here, you'll see how it looks, and then you can go to, where is it? GitHub. There it is. And then you go to GitHub, and then you should be able to go to repositories and and all this. So um, yeah, and you should be able to see all this stuff.
amazing. Oh, looks like
I send
okay,
here the Rustem.no.
Yes.
okay.
That's
They,
.no. That's a Norwegian domain, so that's why it's yeah. It's I just created this just to put all the links, because people ask me for links, and I just collect all the links. Like, this is my blog and this is my other social media and all this. So it's a bit of, it's a kind of, it was a fun project that I've had to play around with. Spend a few hours just putting it all together.
yeah, it's amazing. So amazing content. I think that well, I think the most of people, especially in Brazil, don't pay attention to specifications to from Jakarta specification, Rustam. And sometimes they just follow dependency on projects. For example, Resilience 4J or Spring
Yes.
stuff and something like that, trying to solve the problems, their problems.
Yeah.
About resilience and so on.
Yeah.
But we can see that most of those features we already have in the Jakarta
Yes.
ecosystem.
Yes.
And I used to say that when we are getting experience in software development, sometimes you see valuable things with Jakarta specifications, because Jakarta specification provide you a good foundation to write code and this code probably will live along the way because, as you know, we we cannot face problems
Yep.
with updates and breaking changes and so on.
Mm.
But it's very interesting to see how can we solve those things using Jakarta specification, microprofile specification, and so on. It's very. I got a little question. I don't know if the
Yep.
people on the chat you is interesting too. But for example, about metrics,
Yep.
sometimes I feel that people wants to create dynamic name for the metrics instead of to jump to define a fixed
Huh.
name. I don't
That's
know
it.
if that is that a way to create a dynamic name for the metrics. For example, maybe uh, assign some
Hmm.
method or something like that to provide this name, or it's something that needs to be,
It's
how can I
actually a good
say,
question.
correct.
I haven't tried to do that, but I'm not sure. I, I don't know.
That's
Could you
okay.
do?
That's okay, Rustam.
Actually, I would like to, now I would like to try and test. I think I have a thought or two of how it might work, but I'm not sure if it will. I would be a little bit surprised, but we'll see. I mean, I'll try it. I'll try it and see if I can get it work. But yeah, it will be my evening project, I guess.
Yeah, yeah. Okay, I think that we could, for example, do a workaround. For example,
Yeah.
extract a specific piece of code, then create a method, specific method to this thing, adding some tags and so on. I think that we can solve this kind of problem this way. But it should be
No, because
interesting to see
yeah.
something more, how can I say, dynamic, related to name of metrics. But just like
But
that.
why do you want to create the question that I'm like first of the things was what I'm thinking, and that's a bit of occupational hazard of, I guess, of being a kind of an architect. I always ask why. you know, like why would you want to do that? Are you sure you want to do that? Do you
Yeah.
really need that?
Yeah, yeah.
What's your use
I'm
case?
asking that because sometimes, for example, especially in the legacy code, there's
Yes,
some
yes, yes.
projects that the was managed by specific developers.
Mm.
They created something like that. They created a metrics that, for example, oh, I want to count how many exceptions we got in a specific situation, and
Mhm.
but it's related, it's grabbing some data from the request, from the information that used to be the
Oh, that's what you mean.
destination.
But I mean, then you can create, I think then you should be able to, at least you can handle quite a lot of those things with tags, like I'm doing. So I'm using, I don't know if you saw that. So I'm using the same name for both. Where is it? Let's see. Um, the easiest way is to go through here. So uh,
Could you zoom
zoom in.
zoom on
Yes,
it,
I
please?
can do. I can do that. Let's see. Come on. Oh, I'm zooming in the wrong window. Let me see. No, what's going on? Why
Mm,
am I not able to zoom in? No, I can't actually for some
oh,
really odd reason. Plus, oh yeah, there it is.
oh,
It was
great.
just me being that was a human error. Never mind. So here I'm creating a counted thing, and I give this custom message service name, right? But then I have a perp tags called purpose total. But down here, I just close this. Uh, where is it? Counted? Yes, here. So I have exactly the same name, but I create another tag for it. So I actually create two different tags for exactly the same name of a variable. And you can see them here as well. It will create this application custom messaging service, right? Total. So this is the name coming from uh, messaging service, and also adds total because it actually says, because it's because of this. and then purpose failover, and then you can see them here. You can see purpose failover and purpose total. So it's actually the same name, but it kind of dynamic, right? I mean, it's not really dynamic, but at least I'm able to do two different things with the same name. But there should be a better way of doing this as well. I mean, this is just a kind of the quick and dirty way of doing that, and uh, I will suggest start looking in the specs. So if we go back, but we can dig into this, and I'll tweet about it if I figure something out
Sure,
that is
sure. No, no, no,
very
no
revolutionary.
worries.
But basically, your source of truth is this. If you're going to use it for this, if you're going to use this spec, this is your source of truth, and then this is metrics, and then you have to make sure that you're using the um, right version, right specification version. So if you go here,
Okay,
yeah,
okay, amazing, amazing. Yeah, I'm saying that because, as I said, sometimes we need to migrate applications to new stuff,
yeah.
and sometimes this kind of metrics
So this is the
that,
latest version,
yeah,
5.1. I showed you 5.0. This is actually been updated in the microprofile spec 6.1. So it's a little change somewhere. So that's a
yeah.
good thing to mention. But yeah, sorry, I'm interrupting you.
No, 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 no worries. Actually, I got it. So I'm just asking because sometimes we need to face some kind of migration, and the
Yes.
people, for example, customize those things in a deeper way that they are creating counters, custom counting
Yeah, yeah, yeah.
programmatically, and those things can. How can I say, can stuck the people. Oh, I cannot move it to micro profile matrix because
Yes,
there is a lot of customizations and so on, and it's a nightmare for the people that
for
wants
sure.
to migrate. But I'm just asking, I'm just curious about that. Probably there is some solution
Yeah,
that we can do this. So okay, if there's not, why not to propose? It's open source. Jakarta
exactly.
is an open source, so maybe we could, if you want to do this, so feel free to reach out to people. Looks like on
Yes.
the Jakarta we can find a mail list and
Yep.
start to type it to people, talking to them and so on. So very amazing.
Exactly. Yes.
So, but again, Rustan, I'm so happy to having you here speaking, talking about those things, about new stuff. Yeah, okay, it's not
I'm
just
happy to
you,
be
no, but
there to be here as well. It's been a great pleasure, and it's been great pleasure to see all of you. I mean, to see in all of you, because I cannot see you. I just see you on the chat, but it's really really great. But at least I see two of you in live
yeah.
on the camera,
Hey,
but on the screen. But yeah.
hey, Gabriel, do you want to speak something? Oh, well, we can't. I can't listen you.
Hey, whose dog is that?
Oh,
That's really nice.
the dog's name is Java.
Oh, okay. So we need to ask if Java liked the talk about Java.
it's a recursion problem, man. Java, yes, Java,
It's
yes.
always a recursion problem.
But amazing, Gabriel. I can listen you. I don't
We
know.
cannot hear you. I think you're on mute or something.
Oh, I
Yeah.
Oh
was
yeah, there you go.
muted.
Now
Oh,
you're
oh,
I say,
amazing.
oh, only thanks because you give an amazing talk with a great contact, and the
Thank you so much.
Java join with us to say thank you, Justin. You accept the invite.
Thank you.
Amazing. Amazing. So thanks again, Ruston. Do you want to speak something to the people, maybe doing some more
Yo,
advice and so on? And feel free to do this, man.
It's yeah, like no, feel free to reach out and feel free to say hi, and if you have any questions just ask, and online or any other way. And again, it's been great pleasure to be with you guys again. I really hope that someday I'll be able to join you all live, actually in person, and come to Brazil one day. It would be really really nice. But
Yeah,
for
yeah,
now, I have to survive with just being online.
yeah, yeah. Well, maybe in the future we are trying to organize some events now in Brazil. Maybe in the future
Yeah,
you are most you will be
I'll be happy
our
to.
guest, amazing guest. So
Thank
we
you very
are
much.
happy to having you. And that's it, guys. So that's it, Gabriel. We done
That's it,
this.
Max.
Okay, amazing. So
Thanks, Mark.
Rustam, thanks
Thank you.
again. Gabriel, please, you get
Thank
started.
you, Max.
And
Thank you, Gabriel.
Thank you, guys. And guys, uh, follow us in the social medias for news and lives and events
Yeah.
and the SouJava promote. Follow us and don't lose a news. Thank
okay,
you, guys.
see
Bye
you.
bye.
Bye
Bye
bye.
bye. Bye bye.